Hello my dear students, once again welcome to your online class. Today in this video we will be discussing about a very important topic, that is hydrogen. The hydrogen holds a very special place in a periodic table because it's the first element with the atomic number 1 and as well as the mass number also being 1. So we know that the symbol of hydrogen is H and the atomic number equals to 1 and the mass number is also equals to 1. So that means the hydrogen does not have any neutron in its nucleus. So the hydrogen is only the element in whole of the periodic table that does not have any neutron. So now talking about the position of hydrogen in a periodic table, the hydrogen is at the top of the periodic table in the group 1 along with the rest of the alkali metal. Okay, so alkali metals. All the elements in the first group, they are known as alkali metal and they are metal. But hydrogen, even being a non-metal, is kept in a group 1 along with the alkali metal because most of the properties of hydrogen, it resembles that of the alkali metal. But some of the property of hydrogen, it can also be related to the group 17 element, which are known as halogens. Okay, so some of the properties of hydrogen resembles the alkali metal, whereas the sum of them, they resembles the halogens. So therefore it's said that the hydrogen shows a dual nature, that means the nature of the alkali metal and as well as that of the halogens. So let us see some of the similarities between the hydrogen and the alkalis. So hydrogen, just like the alkali, what it can do, so the first property is the hydrogen, it can lose one electron. Okay, just like rest of the alkali metal, the hydrogen can also lose one electron. Second, by losing one electron, like rest of the metal, it can form a cation. And the third property, you can say that the hydrogen acts as a reducing agent, just like rest of the metals in the group 1. Like if I react copper oxide with a hydrogen, what it can do? It can reduce the copper from a copper oxide, giving copper plus the water. Okay, so these are some of the similarities between the hydrogens and the alkali earth metal. Now coming to the group 17 halogens, so all of the halogens, they have 7 electrons in the outermost orbit. So therefore the halogens, to become stable, they need 1 electron. Thus what happens, just like the halogen, the hydrogen can also gain 1 electron. Okay, gain 1 electron. Okay, thus after gaining 1 electron, it can become anion as well. Okay, so the hydrogen, it can attain a negative charge by gaining 1 electron. So these are the similarities between the halogens and the hydrogens. But apart from the similarity between the hydrogens and apart of the similarity between hydrogen and the alkali metal and the hydrogen and the halogens, the hydrogen also has some of the dissimilarities, the differences between the alkali metal. The first similarity is all of the elements in group 1, they are metals and they are usually solid. But hydrogen is a non-metal and as well as it is a gas. Now coming to the difference between the halogens and the hydrogen, all the oxides of the halogen, okay, so they are acidic in nature, but whereas the oxide of hydrogen is neutral, that is water. Okay, so it's very important for you all to remember the similarity between alkali metal and the hydrogen and the similarity between the halogens and the hydrogen. And also you must remember the difference between the hydrogen and the alkali metal and the hydrogen and the halogens. So that is the first important topic of the chapter hydrogen. Now we shall discuss about the preparation of hydrogen from different metals. So here is the reaction of water with the metal to produce the hydrogen gas. So the formula is basically the metal plus the water, it usually gives the metallic oxide and the hydrogen gas. So if we see here, when the potassium is treated with the water, it gives me the potassium hydroxide and water. Now the potassium, sodium and the calcium. So first 3 reaction occurs even with the cold water. Okay, so the potassium, sodium and calcium, it reacts with the water to produce the respective hydroxide and the hydrogen gas even with the cold water, because potassium, sodium and the calcium, they are the reactive metal in the activity series of the metal. Now coming to the fourth one, the magnesium is quite less reactive than the first three elements. So the magnesium, it reacts with the hot water. Okay, so the magnesium, when treated with the hot or the boiling water, it gives me the magnesium hydroxide and the hydrogen gas. Now coming to the aluminum and zinc, they are the less reactive metal in the activity series. So they react only with the steam. Okay, so they react only with the steam. And finally coming to the reaction of the iron with water, it is seen that it reacts with the steam, and that too the iron must be rare and hot. Okay, so these 7 equation is very important for you to remember. The potassium, sodium and the calcium, when treated with the cold water, it gives the respective hydroxide and the hydrogen gas, but whereas the magnesium, it reacts only with the hot or a boiling water to give a magnesium hydroxide and the hydrogen. Aluminum and zinc, they react with the steam to produce the respective metallic oxide and the hydrogen gas, and finally the iron, it reacts with the steam, and that too when the iron is red hot to produce the ferric oxide and a hydrogen gas. So these are the different methods to produce the hydrogen gas from the different metals. Now the next important topic in this chapter is a activity series of metal. So just now we saw that different metals reacts with the water at a different condition. That means some of the metals, they are active and they react with the cold water, some are inactive, those reacts only with the steam, and that too when the metal is heated up. So depending upon the reactivity series, the reactivity of the metal, we form a series of metal which is known as a activity series of metal. So activity series of the metal is the arrangement of the metal in the decreasing order of their reactivity. That is, the metal at the top are the most reactive and the metal at the bottom is the least reactive. So what are the series, the different metal in the series? You can remember with simply with like Chalcedony never can make a Jew for people. H and chap, C-H-A-A-P. Okay, so this K denotes the sodium, this is potassium, calcium, magnesium, aluminum, zinc, iron, lead, hydrogen. Then we have a copper, then we have H represents the mercury, aluminum, gold, and finally the platinum. Okay, so this is the way you can remember the metal activity series in a order. Chalcedony never can make a Jew for people, hydrogen and chap. Okay, so here we see that the top three, they are very reactive metals. Okay, they react even with the cold water to produce hydrogen, but whereas the aluminum, magnesium, aluminum, zinc and iron, they react with, some react with the hot water and some react with the steam. The lead does not react, and hydrogen also being a non-metal, the question, important question here is the hydrogen being a non-metal is kept in the activity series of metal. It is because the hydrogen, just like we studied, the hydrogen, it shows many properties which are similar to alkali metal. So therefore the hydrogen, even being a non-metal, it's kept in the activity series of metal. And we see that at the bottom, okay, and the least reactive metal is the gold and the platinum. So this is what is meant by the activity series of metal. The arrangement of the metal in the decreasing order of the reactivity is known as activity series of metal. So now coming to the laboratory preparation of hydrogen gas, you have already studied in class 8 as well. So how is it produced? It is produced by the action of a dilute hydrochloric acid on a zinc granules. Okay, so what is done? In a round bottom flask, what is taken? A zinc granule is taken. So here I have zinc. Okay, and from the Thustel funnel, what is done? Drop by drop, the HCl is poured. Okay, so HCl. So when this HCl, it reacts with the zinc, what happens? The hydrogen gas is evolved. So this hydrogen gas can be collected by the downward displacement of water. Okay, so we can collect it by the downward displacement of water. So the reason for the downward displacement of water is the hydrogen gas is insoluble in water, and as well as it is lighter than the air. So it must be collected by the downward displacement of water. So the reaction is when the zinc granule is treated with the HCl, it gives a zinc chloride, ZnCl2 plus the hydrogen gas. Okay, so this is how the the hydrogen is produced in the lab. But now when the hydrogen gas is prepared in the lab with the help of the zinc granule, it contains a lot of impurities. That is the advantage and as well as the disadvantage. The advantage is the zinc contains impurities which acts as a catalyst and enhances the rate of this chemical reaction. But also because of the presence of the impurity, or many of the impurities like other gases along with the hydrogen gas are evolved. So here I have written the list of impurities that is produced along with the hydrogen gas when we prepare a hydrogen in the lab using a zinc granule and a hydrochloric acid. But there is nothing to worry about because each of these impurities can be purified by passing it through a certain solution. Like here you see the first, so the 7 impurities produced are the hydrogen sulfide, sulfur dioxide, the oxides of nitrogen, phosphine, arsine, it is arsine, okay, and the carbon dioxide and the water vapor. So to purify this, what can be done? This hydrogen gas can be passed through each of the solution which will absorb a definite amount of impurities. Like if you pass the gas evolved, so this is connected to the another vessel. So if it is passed through the lead nitrate solution, what does it do? It absorbs the hydrogen sulfide. Now second, it can also be passed through the potassium hydroxide, which is also known as a caustic potash. So when you pass the given product, that is the hydrogen along with the impurities, if you pass it with the caustic potash solution, what happens? The caustic potash, it absorbs the sulfur dioxide, it absorbs the oxides of the nitrogen, and as well as it absorbs the carbon dioxide. And then you can pass it also through a silver nitrate solution which will absorb the phosphine and the arsine. And finally, using a suitable dry agent like a calcium chloride, we can even purify or remove the water vapor that is produced along with the hydrogen gas. Now since the hydrogen gas is very useful, so therefore preparing a hydrogen gas in a small quantity in a lab is not just sufficient. So the hydrogen is produced in a large scale which is known as the industrial preparation of hydrogen, and the process to produce a hydrogen gas in the industry is known as a Bosch process. So the Bosch process involved heating of the coke or the carbon with the water or a steam at a very high temperature at 1000 degrees centigrade to produce the mixture of carbon monoxide and a hydrogen gas which is known as a water gas. And in the next step, this water gas is further treated with a steam in the presence of the catalyst ferric oxide at 450 degrees centigrade to produce the carbon dioxide and the hydrogen gas. And this carbon dioxide can be removed with some special method, and then the hydrogen is obtained in a very large quantity. So this is how the hydrogen is prepared in the large scale. So there are few more important topics related to the hydrogen that we'll be learning in the next video. Thank you.